Okay guys, hello. It is day 48 of 100 days of code with me, Lilly Code, and we are continuing on with our Kubernetes setup. We left off on day 47 looking at Vim. We were trying to get Vim configured because we need to set up this file. So yes, let's watch a bit of the video and find out what we're doing.
Executes whatever is in that configuration file. So let's actually call the configuration file, I don't know, Nginx deployment.
Cool.
And let's go ahead and create a very simplistic, super basic Nginx deployment file. So here I'm gonna create that file.
Okay, so this is where we were. We were editing our Nginx file with Vim. And yeah, that wasn't working. I want to get Vim working. That would be great, but I also want to continue, as always, eager to get going into things that are fruitful. Um, so we're going to just have a look and see if we have, where did we make our Kubernetes folder? In our documents? Maybe in YouTube? Yes, in YouTube. Yes, Kubernetes, and then we should have our file in here. Okay, cool. So I'm going to just open this up with code, because you can open this with code as well to edit these files. Should be able to anyway. I'm definitely presuming you can. So we'll do that. Okay, awesome. Look, we have a file here. This is our Nginx deployment file. So I'm just going to see what it is that she's going to do, and we can add it in from our code editor as opposed to worrying about Vim. Really do want to get Vim set up as well. I'd like to do that with you guys, but we'll worry about that again. So let's just see what she's going to add to the file, and maybe we can add it here and move on and continue with Vim, because at a first pass it didn't work and could be here for a while, just trying to figure that out, and really do want to progress with Kubernetes.
So this is the basic configuration for the deployment. So here I'm just specifying what I want to create. I want to create a deployment, the name of the deployment. You can ignore these labels right now. How many replicas of the pods I want to create. And this block right here, the template and the specification, is a blueprint for the pods. So
This is actually amazing. I just spoke about this in work today, literally about 30 minutes ago. Hence why I even started this Kubernetes tutorial, because I need to learn how to use this for work. So this is awesome. So I just discussed this file a very short while ago with a colleague of mine. And at the time, I was just like, yeah, great, like the file. But hadn't seen it yet. So this is super. But it was making sense, and I knew it was coming in this tutorial as well. Just didn't know it was coming so soon. So that's amazing. So we'll just add all this stuff. Do we literally just have to type all this out? Yeah. Apps, or should there be should we have something in here? Let's just go back and make sure that this shouldn't be auto-generated or something.
Specification for the
Did she just copy all this
do
stuff?
the replica set. See, everything gone. So all the CRUD operations, create, delete, update, etc. happens on the deployment level, and everything underneath just follows automatically. And in a similar way we can create other in practice executes whatever is in that configuration file. So let's actually call the configuration file, I don't know, Nginx deployment.
Okay, so yeah, just want to make
And
sure.
let's go ahead and create a very simplistic, super basic Nginx deployment file. So here I'm gonna create that file. So this is the basic configuration for the deployment.
Okay, super guys. It looks like she just copied and pasted in this configuration. I could even go to I could go somewhere and copy this, but I will not do that. I will type this out. So we have kind deployment. So this is the kind of file it is. And sure, look, we'll learn if we actually type it. Metadata. And this is going to be name. Nginx deployment. Labels. Label. We don't like labels. Everybody can be whatever they want to be. So label app. Oh, sugar. And this is going to be Nginx. And then I'm going to go back a level, spec, back 2 levels. This is at the root, or yeah, that was the correct term. And then spec, we've got replicas, and what this is how many pods you want. So we're starting with 1 pod here, although surely we should always start with 2 pods, or else what's the point? We still are creating a containerized running version of the application. So if there's 1 pod, there's 1 pod. If your pod fails, you just don't have a backup, with replicas being 1, is my understanding of this from the conversation I had in work. So that's cool. And then match labels is gonna be app. And this is where it pulls the name. So your selector is directly related to your name. So Nginx. Then we have our template. Let's go back another level. Yeah, just one template. And metadata. And reminded me of King Julian from Madagascar. Metadata. I don't know why, but I love that little monkey. So metadata, then labels. He's just so funny. Labels. Oh my god, I really want to watch Madagascar now. App. Nginx. Cool. Then we have cartoons, are my favorite. Then we have labels, Nginx, spec, ... And let's see, spec is at the same level as metadata, not as labels. I presume this stuff is important, you know, so let's keep it as exactly as it is. And then we have containers within spec. Containers, I think it is important, to be honest. It should be done just like this as far as I know. Name, because the one in work was set up in a very similar way as well, like just indented and stuff like this, you know. So I think this is important. Nginx 1.16, so I hope that that's the version that I have too. Ports, container, and this is the port that it's actually going to run on. Contain, as far as I know, container, but I'm sure she will explain it to us. So 80, and then we have, that's it.
So here I'm just specifying what I want to create. I want to create a deployment, the name of the deployment. You can ignore these labels right now. How many replicas of the pods I want to create. And this block right here, the template and the specification, is a blueprint for the pods. So specification for the deployment and specification for a pod. And here we're just saying that we want 1 container inside of the pod with Nginx image, and we are going to bind that on port 80. So this is going to be our configuration file, and once we have that, we can apply that configuration.
So I did that. I saved my file. Now we are back in our back in our command prompt. So yes, I'm in the correct command prompt down here. I'll try and open it back up in Bash so you can actually see, so I can zoom in, you know. So let's do that instead of using the regular old. But then some of the commands didn't work, and it said due to my terminal. So if I get that error, look, we can just go back to the regular old terminal. That's fine, but it's just great that I know how to zoom in. I mean, surely I should just Google that and find a simple answer, but hey ho, here you go. We got it going on. So kubectl apply, and then I'm just going to follow along with what she does.
So deployment created. So now if I get pod, I see that Nginx deployment pod was created and it's running. And let's also see that deployment was created 52 seconds ago. And now if I wanted to change something in that deployment, I can actually change my local configuration.
Okay, so we have an issue there with one of the fields. Error validating deployment.metadata unknown field label. So that's okay. Our label, unknown field template. So we just have a few fields that aren't being picked up correctly. So let's just double check, and then if not, I'll try with the flag validate false, which doesn't really seem correct. Well, it's an option there, so if you're going to give me the option, I might just use it. And but first of all, we'll just make sure that nothing is crazy in our file. So I just need to open it back up again because I did close it. Have more chai tea for me. Delicioso. So let's open up our file. Just so good for you as well. Guys, get onto the chai. When you find out the ingredients, you're just like, wow, my body loves me. Or I love my body, I should say. So, and my body loves me. You know, you only get one. Look after it as best you can. Just do your best. So then, just drink some tea. Like, you know, give yourself a feel-good feeling from some tea. So we will now go into Kubernetes here and open up our Nginx deployment.yaml. And check what's going on with this labeled. So we have our app kind metadata name labels. No wonder it couldn't find label. And there was another problem, unknown field template. So where have we done that wrong? So she has app. We should have went back 2 levels here. So coola boola, look at us flying it. So I'll move everything back. Can you see that there? So the first issue was I didn't put the S on label. It needs to be labels. And then the second issue was my template was just at the wrong level. So we can see here app, it was in one. It was underneath match labels here. But it should be under selector. So the ordering is very important in this file. So we'll save that again. And then we'll try that again. We'll just press up to get our last command that we ran. Hit enter, see what happens, and I think we're going to be all good. There we go. So let's continue to watch the video and follow along.
For example, I wanted 2 replicas instead of 1. I can apply that again. Deployment, Nginx deployment configured, and
so sorry guys, I hope the sound isn't all over the place, but I did a sound test and I'm just trying to turn down the microphone when we literally just run the same command when she's talking, because there was like feedback, you know, even though it should be just coming from inside the computer. Maybe I should have just tried to reconfigure it. Anyway, we will continue. So
as you see, the difference here is that Kubernetes can detect if the Nginx deployment doesn't exist yet. It's going to create one. But if it already exists and I apply the configuration file again, it's going to know that it should update it instead of creating a new one. So if I do get deployment, I see this is the old one or the old deployment. And if I do kubectl get pod, I see the old one is still there, and a new one got created because I increased the replica count. Which means that with kubectl apply, you can both create and update a component. And obviously you can do kubectl with services, volumes, any other Kubernetes components, just like we did it with the deployment. So in the next video, I'm going to break down the syntax of the configuration file, which is pretty logical and simple actually to understand. And I'm going to explain all the different attributes and what they mean, so you can write your own configuration files for different components. So to summarize, we've looked at a couple of kubectl commands in this video. We saw how to create a component like deployment, how to edit it and delete it. We saw how to get status of pods, deployments, replica sets, etc. We also logged on the console whatever application is writing it to the console in the pod. And we saw how to get a terminal of a running container using kubectl exec. And finally, we saw how to use a Kubernetes configuration file to create and update components using the kubectl apply command. And last but not least, we saw kubectl describe command, which is useful when a container isn't starting in a pod and you want to get some additional troubleshooting information about the pod. In this video, I'm going to show you the syntax and the contents of Kubernetes configuration file, which is the main tool for creating and configuring components in Kubernetes cluster. If you've seen large configuration files, it might seem overwhelming, but in reality, it's pretty simple and intuitive, and also very logically structured. So let's go through it step by step. So here I have examples of a deployment and service configuration files side by side. So the first thing is that every configuration file in Kubernetes has three parts. The first part is where the metadata of that component that you're creating resides. One of the metadata is obviously name of the component itself. The second part in the configuration file is specification. So each component's configuration file will have a specification where you basically put every kind of configuration that you want to apply for that component. The first two lines here, as you see, is just declaring what you want to create. Here we are creating deployment, and here we're creating a service. And this is basically that you have to look up for each component. There's a different API version. So now inside of the specification part, obviously the attributes will be specific to the kind of a component that you're creating. So deployment will have its own attributes that only apply for deployment, and the service will have its own stuff. But I said there are three parts of a configuration file, and we just see metadata and the specification. So where's the third part? So the third part will be a status, but it's going to be automatically generated and added by Kubernetes. So the way it works is that Kubernetes will always compare what is the desired state and what is the actual state or the status of that component. And if the status and desired state do not match, then Kubernetes knows there's something to be fixed there, so it's going to try to fix it. And this is the basis of the self-healing feature that Kubernetes provides. For example, here you specify you want 2 replicas of Nginx deployment. So when you apply this, when you actually create the deployment using this configuration file, that's what apply means, Kubernetes will add here the status of your deployment, and it will update that state continuously. So for example, if a status at some point will say just 1 replica is running, then Kubernetes will compare that status with the specification and will know there is a problem there, another replica needs to be created ASAP. Now, another interesting question here is, where does Kubernetes actually get that status data to automatically add here or update continuously? That information comes from the etcd. Remember the cluster brain, one of the master processes that actually stores the cluster data. So etcd holds at any time the current status of any Kubernetes component, and that's where the status information comes from. So as you see, the format of the configuration files is YAML. That's why the extension here. And generally, it's pretty straightforward to understand. It's a very simple format, but YAML is very strict about the indentations. So for example, if you have something wrongly indented here, your file will be invalid. So what I do, especially if I have a configuration file that has 200 lines, it's pretty long, I usually use some YAML online validator to see where I need to fix that. But other than that, it's pretty simple. Another thing is, where do you actually store those configuration files? A usual practice is to store them with your code, because since the deployment and service is going to be applied to your application, it's a good practice to store these configuration files in your application code. So usually it will be part of the whole infrastructure as a code concept. Or you can also have its own Git repository just for the configuration files. So in the previous video, I showed you that deployments manage the pods that are below them. So whenever you edit something in a deployment, it kind of cascades down to all the pods that it manages. And whenever you want to create some pods, you would actually create a deployment and it will take care of the rest. So how does this happen, or where is this whole thing defined in the configuration? So here in the specification part of a deployment, you see a template. And if I expand it, you see the template also has its own metadata and specification. So it's basically a configuration file inside of a configuration file. And the reason for it is that this configuration applies to a pod. So pod should have its own configuration inside of the deployment's configuration file. And that's how all the deployments will be defined. And this is going to be the blueprint for a pod, like which image it should be based on, which port it should open, what is going to be the name of a container, etc. So the way the connection is established is using labels and selectors. So as you see, metadata part contains the labels, and the specification part contains selectors. It's pretty simple. In a metadata, you give a component like deployment or pod a key value pair, and it could be any key value pair that you think of. In this case, we have app nginx, and that label just sticks to that component. So we give pods created using this blueprint label app nginx, and we tell the deployment to connect or to match all the labels with app nginx to create that connection. So this way deployment will know which pods belong to it. Now deployment has its own label, app nginx, and these two labels are used by the service selector. So in the specification of a service, we define a selector which basically makes a connection between the service and the deployment or its pods, because service must know which pods are kind of registered with it. So which pods belong to that service. And that connection is made through the selector of the label. And we're going to see that in a demo. So another thing that must be configured in service and pod is the ports. So if I expand this, I see that service has its ports configuration. And the container inside of a pod is obviously running or needs to run at some port, right? So how this is configured is basically service has a port where the service itself is accessible at. So if other service sends a request to Nginx service here, it needs to send it on port 80. But the service needs to know to which pod it should forward the request, but also at which port is that pod listening. And that is the target port. So this one should match the container port. And with that, we have our deployment and service basic configurations done. And to note here, most of these attributes that you see here in both parts are required. So this will actually be the minimum configuration for deployment and service. So once we have those files, let's actually apply them or create components using them. So let's head over to the console. And here I'm going to create both deployment and service. So kubectl apply nginx deployment, create it, and nginx service. So now if I get the pods, I see two replicas are running because that's how we defined it here. And we have our service as well, which is Nginx service. This is a default service. It's always there. This is the one we created. And it's listening on port 80 as we specified. Now, how can we validate that the service has the right pods that it forwards the requests to? We can do it using kubectl describe service and the service name. And here you see the endpoints where you have all this status information here, like things that we define in the configuration, like app selector, etc. We have the target port that we define, and we have the endpoints here. And this must be the IP addresses and ports of the pods that the service must forward the request to. So how do we know that these are the IP addresses of the right pods? Because with kubectl get pod, you don't get this information. So the way we do it, or way we find that out, is using get pod, and then you do -o, which is for output, and then we want more information. So oy.
Okay, so I seem to have an error when I run that same command. So let's just make sure everything is perfect there. So kubectl describe. I'm following this command here. Service nginx service. So let's just go up and make sure, because we did just check our service, get service. So if we get our service, it seems like our service name is Kubernetes. Was that her name? Or, yeah, her one. No. We don't have a service. So kubectl get service. She has Kubernetes and nginx service. And we just have Kubernetes. So let's try and describe that service instead, and then just see what's going down around the town. So I'll say Kubernetes. Probably saying that really weird, but I think it's said a bit weird. So what if I just do Kubernetes then? Kubernetes. Okay. So we have that service, this Kubernetes service. We don't have the nginx one that she's talking about. But that's all right on the night. We'll just continue, because let's see what happens. I'm happy with that. So let's just keep on watching.
And here we see more columns here. So we have the name and status, ready, etc. But we also have the IP address. So here is the IP address endpoint specified here. And this is the other one. So we know that the service has right endpoints. So now let's see the third part of the configuration file, which is a status that Kubernetes automatically generated. Because with kubectl get pod, you don't get this information. So the way we do it, or way we find that out, is using get pod, and then you do -o, which is for output, and then we want more information. So oy. And here we see.
Okay, so just going to run that same command. So kubectl get pod o wide, get pod flag o wide. So when we have these dashes in the terminal, as far as I know, they're always flags. So that's a flag when you pass in the dash and then you tell it something. So this is the open, I presume, or just open wide. Give me more information on this. And open it. Open is the flag, because this little dash represents a flag normally. So then we can see what we have here. We can see our IP address, and this should match up to something up here, which it does not. But okay, I'm just gonna keep on going. Yeah, let's just keep on going and see what's going to happen.
More columns here. So we have the name and status, ready, etc. But we also have the IP address. So here is the IP address endpoint specified here. And this is the other one. So we know that the service has right endpoints. So now let's see the third part of the configuration file, which is a status that Kubernetes automatically generated. And the way to do it is we can get the deployment, nginx deployment, in a YAML format. So when I execute this command, I will get the resulting, or the updated configuration of my deployment, which actually resides in the etcd, because etcd stores the status of the whole cluster, including every component. So if I do this, I'll get the YAML output in my console, but I want it in the file. So I'm gonna save it into nginx deployment result.
So we're just going to add that to this command like she has done. So we save it into nginx deployment result. and that's just going to save this auto-generated information. So this third part of the equation that's auto-made by Kubernetes itself, and we've saved it into a file now. So let's keep watching and see what's going down.
And I'm going to save it there. And I'm going to open it in my editor next to the original one. So as you see, a lot of stuff has been added, but let's just see the status part. So all of this is automatically added and updated constantly by Kubernetes. So it says how many replicas are running, what the state of those replicas, and some other information. So this part can also be helpful when debugging. So that's the status, but also if you noticed, other stuff has been added in the metadata and specification part as well. So for example, creation timestamp, when was the component created, is automatically added by Kubernetes because it is a metadata. Some unique ID, etc. You don't have to care about it. And in the specification part, it just adds some defaults for that component. But again, you don't have to care or understand most of these attributes. But one thing to note here is that if you, for example, want to copy a deployment that you already have using maybe automated scripts, you will have to remove and get rid of most of this generated stuff. So you have to clean that deployment configuration file first, and then you can create another deployment from that blueprint configuration. So that's it with this video. So from now on, we're going to be working with the configuration files. So for example, if I want to delete the deployment and the service, I can do it using that file, configuration file as well, using delete and like this. The deployment will be gone, and I can do the same for service. All right, so using
Okay, cool. So that's great. We did auto-generate that file. I could see it there. I hope you guys seen that in my Visual Studio Code, and we can see all the stuff she's talking about. So we have our creation timestamp. No, no time for me, eh? You ain't got no time for me. So there we go, our creation timestamp, and there is the time and the date. So now we're going to delete those files as instructed.
kubectl apply and kubectl delete. You can basically
as instructed by Nana. So let's do that now. So we're going to run, there we go, kubectl delete. If you can see, it's just here. So with this command and then this command too. So we're just going to delete both of those files. So delete, we're passing an F flag. I'm not sure what that means, but it's a F flag. Nginx deployment find to delete it, perhaps. .yaml, but that's a guess. And cool, deleted. And then we will do the same for our other file, which was Nginx service. So cool. Just replace this. You just press up to get back that last command, service, like so. And it does not exist. What have I done? I've spelled it wrong. So kubectl delete Nginx service. We could never find that service. Yeah, so I must have deleted it somehow previously, because when we went looking for both of those services, we didn't have the Nginx one. So yes, I don't have it to delete. Let me just make sure. Nginx service, like, yeah, there's nothing else different, and I didn't see that file when we went looking for it. So let's continue and listen to Nana.
Basically work with the configuration files. In this video, we're going to deploy two applications, MongoDB and MongoExpress. And I chose these two because it demonstrates really well a typical simple setup of a web application and its database. So you can apply this to any similar setup you have. So let's see how we're going to do this. So first we will create a MongoDB pod. And in order to talk to that pod, we are going to need a service. And we're going to create an internal service, which basically means that no external requests are allowed to the pod. Only components inside the same cluster can talk to it. And that's what we want. Then we're going to create a MongoExpress deployment. One, we're going to need a database URL of MongoDB so that MongoExpress can connect to it. And the second one is credentials, so username and password of the database so that it can authenticate. So the way we can pass this information to MongoExpress deployment is through its deployment configuration file. through environmental variables. That's how the application is configured. So we're going to create a config map that contains database URL, and we're going to create a secret that contains the credentials. And we're going to reference both inside of that deployment file. So once we have that set up, we're going to need Mongo Express to be accessible through a browser. In order to do that, we're going to create an external service that will allow external requests to talk to the pod. So the URL will be HTTP, IP address of the node, and the service port. So with this setup, the request flow will now look like this. So the request comes from the browser, and it goes to the external service of the Mongo Express, which will then forward it to the Mongo Express pod. The pod will then connect to internal service of MongoDB. That's basically the database URL here. And it will forward it then to MongoDB pod, where it will authenticate the request using the credentials. So now let's go and create this whole setup using Kubernetes configuration files. Let's dive right into it and create the whole setup. So first of all, I have a Minikube cluster running. If I do kubectl get all, which basically gets me all the components that are inside the cluster, I only have a default Kubernetes service. So my cluster is empty and I'm starting from scratch. So the first thing that I said we're going to do is create a MongoDB deployment. I usually create it in an editor. So I'm going to go to Visual Studio Code and
my microphone was turned down. Sorry, you probably caught none of that. So basically in work today, when I had that conversation with my colleague, I was informed that we actually don't use Mongo, and he told me I could skip ahead, but I didn't know what he was talking about because I hadn't got here yet. So anyway, maybe you heard it all and I just said the exact same thing again, but it's irrelevant. Well, let's just move on. So I think I'm going to skip the Mongo part and just move to the next bit because I know we do not use this and I want to learn this specifically for work at the moment. Obviously all learning is learning. I mean, it's for myself, it's for work, but I do need to implement this. So in the interest of quickest learning for the job, I'm going to skip this section. So yes, that's the plan actually. I'm going to skip this section and just go to the next one because I don't need this. So.
In this video, we're going to go through the usages of a namespace and the best practices of when and how to use a namespace. First of all, what is a namespace in Kubernetes? In Kubernetes cluster, you can organize resources in namespaces. So you can have multiple namespaces in a cluster. You can think of a namespace as a virtual cluster inside of a Kubernetes cluster. Now, when you create a cluster, by default, Kubernetes gives you namespaces out of the box. So in the command line, if I type kubectl get namespaces, I see the list of those out of the box namespaces that Kubernetes offers. And let's go through them one by one. Type kubectl get namespaces, I see the list of those out of the box namespaces that Kubernetes offers. And let's go through them one by one. The Kubernetes dashboard namespace is shipped automatically in Minikube, so it's specific to Minikube installation. You will not have this in a standard cluster. The first one is kubesystem. Kubesystem namespace is not meant for your use. So basically you shouldn't create anything or shouldn't modify anything in kubesystem namespace. The components that are deployed in the namespace are the system processes. They're from master, managing processes, or kubectl, etc. The next one is kubepublic. And what kubepublic contains is basically the publicly accessible data. It has a config map that contains cluster information which is accessible even without authentication. So if I type here kubectl cluster info, this is the output that I get through that information. And the third one is kubenode lease, which is actually a recent addition to Kubernetes. And the purpose of that namespace is that it holds information about the heartbeats of nodes. So each node basically gets its own object that contains the information about that node's availability. And the fourth namespace is the default namespace. And default namespace is the one that you're going to be using to create the resources at the beginning if you haven't created a new namespace. But of course, you can add and create new namespaces. And the way that you can do it is using kubectl create namespace command with the name of the namespace. So I can create my namespace, and if I do kubectl get namespaces, I see that in my list now. Another way to create namespaces is using a namespace configuration file, which I think is a better way to create namespaces because you also have a history in your configuration file repository of what resources you created in a cluster. Okay, so now we saw what namespaces are and that you can create new ones and that Kubernetes offers some of them by default. But the question is, what is the need for namespaces? When should you create them and how you should use them? And the first use case of using or creating your own namespaces is the following. Imagine you have only default namespace, which is provided by Kubernetes, and you create all your resources in that default namespace. If you have a complex application that has multiple deployments, which create replicas of many pods, and you have resources like services and config maps, etc., very soon your default namespace is going to be filled with different components. And it will be really difficult to have an overview of what's in there, especially if we have multiple users creating stuff inside. So a better way to use namespaces in this case is to group resources into namespaces. So for example, you can have a database namespace where you deploy your database and all its required resources. And you can have a monitoring namespace where you deploy the Prometheus and all the stuff that it needs. You can also have Elasticstack namespace where all the Elasticsearch, Kibana, etc. resources go, and you can have Nginx ingress resources. So just one way of logically grouping your resources inside of the cluster. Now, according to the official documentation of Kubernetes, you shouldn't use namespaces if you have smaller projects and up to 10 users. I personally think that it's always a good idea to group your resources in namespaces because, as I said, even if you have a small project and 10 users, you might still need some additional resources for your application, like, logging system and monitoring system. And even with the minimum setup, it can already get too much to just throw everything in a default namespace. Another use case where you will need to use namespaces if you have multiple teams. So imagine this scenario, you have two teams that use the same cluster. And one team deploys an application which is called My App Deployment. That's the name of the deployment they create. And that deployment has its certain configuration. Now, if another team had a deployment that accidentally had the same name, but a different configuration, and they created the deployment or they applied it, they would overwrite the first team's deployment. And if they're using, for example, a Jenkins or some automated way to deploy that application or to create the deployment, they wouldn't even know that they overwrote or disrupted another team's deployment. So to avoid such kind of conflicts, again, you can use namespaces so that each team can work in their own namespace without disrupting the other. Another use case for using namespaces is, let's say you have one cluster and you want to host both staging and development environment in the same cluster. And the reason for that is that, for example, if you're using something like Nginx controller or Elasticstack, used for logging, for example, you can deploy it in one cluster and use it for both environments. In that way, you don't have to deploy these common resources twice in two different clusters. So now the staging can use both resources as well as the development environment. Another use case for using namespaces is when you use blue-green deployment for your application, which means that in the same cluster, you want to have two different versions of production. So the one that is active, that is in production now, and another one that is going to be the next production version. The versions of the applications in those blue and green production namespaces will be different. However, the same as we saw before in staging and development, these namespaces might need to use the same resources, like again, Nginx controller or Elasticstack. And this way, again, they can both use this common shared resources without having to set up a separate cluster. So one more use case for using namespaces is to limit the resources and access to namespaces when you're working with multiple teams. So again, we have a scenario where we have two teams working in the same cluster, and each one of them has their own namespace. So what you can do in this scenario is that you can give the teams access to only their namespace, so they can only be able to create, update, delete resources in their own namespace, but they can't do anything in the other namespaces. In this way,
I just know that you can do this, give people access to the different namespaces with the use of Google Drive. So you can create a group in Google, and then you can link that group to the namespace, and that's how you can say exactly who is allowed interact with this namespace or not. So we will continue to chat, but it's very simple. You just set up a little group on Google, and then you provide that URL. I'm sure you provide that URL, and then people get access to that particular namespace. So very easy to actually implement this, what she's talking about. And all of this might seem a bit crazy, but honestly, if you watch this video from her, I think actually it's quite logical to set this up. I don't think it's too difficult. So actually, give it a go. From my experience and what I've learned so far, it's all very logical. The configuration files are logical. It's logical. So, and there's loads of resources out there as well. So just some words of encouragement that this isn't difficult. If you're looking at it going, this is a bit mad, don't worry, it'll fall into place. It's not too mad. Okay.
Even restrict or even minimize the risk of one team accidentally interfering with another team's work. So each one has their own secured, isolated environment. Additional thing that you can do on a namespace level is limit the resources that each namespace consumes, because if you have a cluster with limited resources, you want to give each team a share of resources for their application. So if one team, let's say, consumes too much resources, then other teams will eventually have much less, and their applications may not schedule because the cluster will run out of the resources. So what you can do is that per namespace, you can define resource quotas that limit how much CPU, RAM, storage resources one namespace can use. So I hope walking through these scenarios helped you analyze in which use cases and how you should use namespaces in your specific project. There are several characteristics that you should consider before deciding how to group and how to use namespaces. The first one is that you can't access most of the resources from another namespace. So for example, if you have a configuration map in project A namespace that references the database service, you can't use that config map in project B namespace, but instead you will have to create the same config map that also references the database service. So each namespace will define or must define its own config map, even if it's the same reference. And the same applies to secret. So for example, if you have credentials of a shared service, you will have to create that secret in each namespace where you are going to need that. However, a resource that you can share across namespaces is a service. And that's what we saw in the previous slide. So config map in project B namespace references service that is going to be used eventually in a pod. And the way it works is that in a config map definition, the database URL, in addition to its name, which is MySQL service, will have a namespace at the end. So using that URL, you can actually access services from other namespaces, which is a very practical thing. And this is how you can actually use shared resources like Elasticsearch or Nginx from other namespaces. And one more characteristic is that we saw that most of the components, resources can be created within a namespace, but there are some components in Kubernetes, they're not namespaced, so to say. So basically they live just globally in the cluster, and you can't isolate them or put them in a certain namespace. And examples of such resources are volume or persistent volume and node. So basically, when you create the volume, it's going to be accessible throughout the whole cluster because it's not in a namespace. And you can actually list components that are not bound to a namespace using a command kubectl API resources -- namespaced false. And the same way, you can also list all the resources that are bound to a namespace using namespace true. So now that you've learned what the namespaces are, why to use them, in which cases it makes sense to use them in which way, and also some characteristics that you should consider, let's actually see how to create components in a namespace. In the last example, we've created components using configuration files, and nowhere there we have defined a namespace. So what happens is by default, if you don't provide a namespace to a component, it creates them in a default namespace. So if I apply this config map component, and let's do that actually right now. So kubectl apply -f config map. If I apply that and I do kubectl get config,
Okay, so let's give this a whirl, what she's doing right now, because that's useful. So we'll try out these commands. So we have kubectl apply space apply f MySQL SQL -config map .yaml. That should just create it first though, so what's wrong there? kubectl apply f MySQL config map.yaml. Is this because we just skipped some of it, or I don't know, so let's just keep watching for a moment.
config map, my config map was created in a default namespace. And notice that even in the kubectl get config map command, I didn't use a namespace because kubectl get or kubectl commands, they take the default namespace as a default. So kubectl get config map is actually same as kubectl get config map -n or namespace and default namespace. So these are the same commands, it's just a shortcut because it takes default as a default namespace. Okay, so one way that I can create this config map in a specific namespace is using kubectl apply command, but adding flag namespace and the namespace name. So this will create config map in my namespace. And this is one way.
So to be honest, I don't expect that to work either for us, because if it's not creating it anyway, adding a name to it, like giving it a name, isn't going to create it either. So we will just continue to watch.
way to do it. Another way is inside the configuration file itself. So I can adjust this config map configuration file to include the information about the destination namespace itself. So in the metadata, I can add a namespace attribute. So if I apply this configuration file again using kubectl apply, and now if I want to get the component that I created in this specific namespace, then I have to add the option or the flag to kubectl get command, because as I said, by default, it will check only in the default namespace. So I recommend using the namespace attribute in a configuration file instead of providing it to the kubectl command, because one, it's better documented, so you know by just looking at the configuration file where the component is getting created, because that could be an important information. And second, if you're using automated deployment where you're just applying the configuration files, then again, this will be a more convenient way to do it. Now, if, for example, we take a scenario where one team gets their own namespace and they has to work entirely in that namespace, it could be pretty annoying to have to add this namespace tag to every kubectl command. So in order to make it more convenient, there is a way to change this default or active namespace, which is default namespace, to whatever namespace you choose. And Kubernetes or kubectl doesn't have any out-of-the-box solution for that, but there's a tool called kubens or kubens, and you have to install the tool. So on Mac, so I'm gonna execute brew install kubectx. So this will install kubens tool as well. So once I have the kubens installed, I can just execute kubens command, and this will give me a list of all the namespaces and highlight the one that is active, which is default right now. And if I want to change the active namespace, I can do kubens my namespace, and this will switch the active namespace. So if I do kubens now, I see that active one is my namespace. So now I can execute kubectl commands without providing my namespace.
Okay, cool guys. So she used brew here to install her kubens, and I knew that I do not have homebrew because I'm running on a Windows machine, not on a Mac. So as a result, I tried to do it with Choco, because Chocolatey is the corresponding package manager that you can use. So it says I'm not running from an elevated command shell, so I should be in a CMD or a PowerShell, which is all good because we can do that. So instead, I will just open up my PowerShell. So here's Windows PowerShell. I will run as administrator. And then I'll get into my folder. Actually, don't know about that. Last time I tried to CD into the folder. Let's just do it from a regular old command prompt. So here we are. We're in our command prompt here, and I can do choco install. Sorry, this probably looks a bit mad. Choco install kubens or cube ns. I like Cubans, I think. Chocolatey detected. Oh, snapper like a jack. So it's still not an elevated command shell. So let's have a look at our PowerShell, which it actually tells us we can use at our PowerShell. But like CMD, that's my CMD. So as far as I'm concerned, that should have worked as well. So I tried to get into my documents from here and it wouldn't let me. So we're going to have to start next time from where we've left off here now. So what I'll do is I will continue to install this. We're not even going to be able to rename our namespace anyway. I might just go back and do the MongoDB section so I can follow along what's next. So she's just explaining things, so I do like, following along. It's good for learning. So we'll just see, you know, maybe I'll continue, and because it would be great to watch it, see how I get on, and I can always go back and do it. And then also there's loads of other Kubernetes tutorials, and she even has loads, Tech World with Nana. So thank you so much, Nana, for your fantastic content. And thank you so much, all of my wonderful watchers who are following me on this journey. I'm so grateful, and I hope you have an absolutely splendid day. And just thanks so much for joining me. It's fabulous. So have a great day, guys. I will chat to you again tomorrow. And thanks.